This video will provide you with brief explanations for the 5 math problems you looked at from Activate Week 1. So number 1 asks you which of the following statements are true, and this deals with the various types of numbers that you encounter. B is the correct answer, but really to make this make sense, you need to think about the different types of numbers, and you can look at a diagram that's similar to this one. So in most math classes, you deal with the real numbers, starting with naturals. That's what you learn to count with. The whole numbers, throw in 0. Integers are whole numbers and their opposites. Rational numbers are numbers that can be written as fractions or as decimals that either repeat or terminate. Another subset of real numbers are called the irrational numbers. Pi is probably the most common that we come into contact with in a high school setting, but you also have some radicals in that set of numbers. There are also numbers called imaginary numbers, and you encounter those as you advance in your study in mathematics. When you put the real numbers together with the imaginary numbers, that's where you get essentially all of the numbers or your complex numbers. So when you go back and look at your options for number 1, every real number is rational. That is not true. Every rational is real. Some rational numbers are integers. Yes, that is true. Not all rational numbers are integers. Some are fractions. All integers are whole numbers. That is not true. An integer can be negative, and that's not a whole number. D is kind of tricky. All non-negative real numbers are positive. Again, that is not true because 0 is a non-negative real number, but it's not positive. It's neither. And then the number 3.1416 is irrational. That's also tricky because it's wanting you to think about pi. Pi itself is irrational, but the approximation to pi is not. That's technically a terminating decimal. So again, B is your correct answer. Question number 2 kind of piggybacks off of that. It says, which of the following is not a real number? C is the correct answer because you cannot divide by 0. And when you take the ACT, you are allowed to have a calculator. And if you enter 8 divided by 0 into your calculator, you will get an error message of some kind. So C is the correct answer. That is not real because you cannot divide by 0. Number 3 deals with area. And you're given a diagram where the long sides are parallel. The right end is capped with a semicircle. That means half circle. The left end has a triangular extension as shown. So to find area, what you essentially want to do is split or divide up the diagram so that you have 3 pieces. You have a semicircle. So the area for a circle is pi r squared. But since you're only doing half of that, it would be 1/2 times pi times the radius, which is 2 squared. And when you crunch those numbers, usually you want to leave pi in your calculations. As you can see by your answer choices over here, they all have a pi in them. 2 squared is 4, and since you're multiplying half, this would be 2 pi. Now that can help you eliminate an answer choice. You can eliminate answer choice F as you start, answer choice H as you start to look towards answers. Then as you look at the rectangle, the area of a rectangle is length times width. So when you look at the rectangle, the length here is 12 times the width. Well, this is a radius,
and it's indicated as having a length of 2. So this whole piece would be the diameter, an additional 2. So the width of the rectangle is 4. And then 12 times 4 gives you 48. Then when you look at the little triangle down at the bottom, the long sides are parallel, so this is also a right angle. If this is 45 degrees, this is also 45 degrees. If the whole side is 7 and this much is 4, then you have a 3 here. And since both of your base angles there are congruent, 45 and 45, the other side is also 3. And the triangle area then would be 1/2 times base times height. And if you remember, when you're looking at a triangle, your base and your height are perpendicular, so that's 1/2 times 3 times 3. As you look at your answer choices, you don't see any decimals, so 3 times 3 is 9, and 1/2 of 9 is 9/2. So then when you're wanting to write your area for the whole picture, you've got something like 9/2 plus 48 plus 2 pi. And if you look, you don't see anything that quite resembles that. But if you start to look at some of the others, I see a fraction on K. I almost like F, but it's got a 48 instead of a 98. So what this problem is trying to get you to do is factor out a fraction. In other words, if you pull out a half from each of these numbers, if you pull out a half from 9/2, you're left with 9. Okay. A half will go into 48, or you can pull out, how many halves can you pull out of 48? And that would be 96 halves. And then you have 2 pi. So don't worry about the pi, but think about the 2. How many halves do you have in the number 2? Well, you have 4 halves, and that pi just kind of comes along with it. And then you can see it's starting to look more like K. The only thing is, now you have to put together the 9 and the 96. 9 and 96 makes 105, so K is your correct answer. As we look at number 4, if you've not encountered logarithms in any of your math classes, number 4 is a bit challenging. And even if you have seen logs, you have to think back to those logarithmic properties. And what you're essentially trying to do is to rewrite this expression on the end in terms of these 3 pieces that you've been given. So your base is 2, log base 2 of 35 square root 6. So I know that I've got 35 right here, and I can rewrite 35 as 5 times 7, because I see I have log base 2 of 5 and log base 2 of 7. And if you remember, you can expand logarithms. If you're taking the log of a product, you can expand that product using addition. So instead of saying log base 2 of 35, I will have log base 2 of 5 plus log base 2 of 7. I'm also multiplying by that square root of 6, so I can also say plus log base 2 of the square root of 6. So as we continue to simplify, log base 2 of 5, well, that is right here, so that's B. Log base 2 of 7, that's right here, so that's C. But we still need to do a little work with that last logarithm. Now, if you remember, the square root can be rewritten as a power, so that's 6 to the 1/2 power. Then you can use your power rule when you're thinking about logarithms, and that 1/2 comes around to the front. So you've got 1/2 times log base 2 of 6. And as you start to look at your answer choices, you start to look at what you're given, you need to take a look at this. So you think, okay, how can I get a 3 into the mix? Well, remember, 6 is 2 times 3. So again, using that product rule, you can call that log base 2 of 2 plus log base 2 of 3, with that 1/2 still hanging out in front. Then as you continue to simplify, log base 2 of 2. Well, you don't have anything in the problem statement that addresses log base 2 of 2, but you're asked to then think about, okay, 2 to the what power gives you 2, because remember, a logarithm is simply a fancy exponent. So 2 to the first power gives you 2. So I can replace log base 2 of 2 with simply a 1. And then that last logarithmic expression, again, was up in the problem statement. Log base 2 of 3 is equal to a. So I replace that portion with a. And then as you start to compare answer choices, you have something now that matches up with answer choice A. The last problem that we're going to look at should be accessible to anybody in a high school math class because it's simply a linear equation. Most of you would probably think, well, I need to get this equation in slope-intercept form so I can figure out what the slope and the y-intercept are. So that means you're going to isolate the y. In other words, you're getting y by itself. So the first thing you do is subtract the 2x to the other side of the equation. Then we're going to divide both sides of the equation by 5 so that y equals negative 2/5 x plus 7/5. And then as you start to look at your answer choices, I first focus on my slope being negative. Well, A does not have a negative slope. B does. C does, but D does not have a negative slope. So we can eliminate those two answer choices. Your y-intercept is 7/5. So that's 1 2/5. So that point on B, or this point on C, should be 1 2/5. I'm starting to lean toward answer choice B. But before I make my decision, I'm going to think about, again, what slope means. So I'm going to go back to slope. Slope is rise over run. So this would be how much my line falls versus how much my line goes to the right. So it falls less, goes to the right more. So it's not a very steep line. Therefore, B would be my final answer choice. Another approach to this problem would be to go back to your original equation and find the x and y intercepts by letting each of your variables be 0 and then comparing the x and y intercepts of each graph that you're provided.